Okay, next we're going to talk about topic 4.4, so which is known as the right angle trigonometry. So we're going to talk about trigonometric problem that concern so when we have right angle triangle. So basically, what is a right triangle? So right triangle or right angle triangle is actually a triangle that we use to describe a triangle that for which like one of them has a right angle. So right angle is actually 90-degree. So when you have a triangle and one of the angle in there is actually a right triangle, so that is called as being a right triangle. And there is like a couple of very important terms that you should know. And I think I've explained this in the previous subtopic actually, so you have come across this before. So if our angle theta is going to be here, so the sides which is right next to the angle is known as the adjacent, so which is right next to it. And whatever that is opposite the angle is called as being the opposite. And the longest line, so when we have a triangle, we have three lines. So the longest line, so which is going to be right here, so this is called as being the hypotenuse. So of course there are what I call the trigonometric property that we can relate between the value of adjacent, opposite, and hypotenuse, and I've shown this to you before. So the fact that the easiest way to remember this is going to be so ka to wa. So this is going to be ka, and this is going to be to wa, and I'm pretty sure that you already have your own way on how to memorize this, so no problem, you can use that. And for the case of cosecant, of course, you just have to flip this around. So that is why, because cosecant is 1 over sine. So you simply flip around between the hypotenuse and opposite. And of course, secant is going to be 1 over cos theta. So you flip whatever that you have at the top. And the same goes for cotangent, because cotangent is 1 over tangent. Okay, so here it's telling you that if we have two right triangles, and we have the same angle, so basically here this is theta and this is theta as well, it doesn't matter if like the size is different. Like for example, this triangle over here is actually 1/3 smaller than previous one, or this one is actually 3 times smaller the first one. Okay, so if the angle is actually the same, automatically the angles in terms of the trigonometric functions are also going to be the same. It doesn't matter if one is actually multiple times bigger than the other one, but as long as the angle is the same, the trigonometric function is also going to be the same. For example, over here, the smaller triangle have sine theta equal 3 over 5, but then again, the bigger triangle is also, when we simplify, is also going to give you a value of sine theta equal 3 over 5. So size doesn't matter, as long as angle is the same, automatically the trigonometric function is also going to be the same. Okay, so here I have a right triangle. How do we know it's a right triangle? Because one of the angle is given by a value of 90-degree. So it says over here, a triangle is given as the following figure. So we're going to find the values of cos theta and cotangent theta. So here, so if you notice, this is going to be my angle. So D over here is going to be our adjacent. So it is right next to the angle. So it's known as the adjacent side. And 7 is opposite to the theta. So it's going to be called as being the opposite. And if we have a look between D7 and 25, of course, 25 is going to be the longest. The longest is going to be the opposite to the, for right triangle, is going to be opposite to the 90-degree. So therefore 25 is going to be the hypotenuse. Okay, so how do we find the value of cos theta? So first of all, so what is cos? Cos is going to be ka, so which is going to be adjacent over hypotenuse. So first of all, what we need to do is we need to figure out what is going to be the value of D. And I'm pretty sure you are familiar with the Pythagorean theorem, or theorem of Pythagoras. So the fact that the hypotenuse, no, instead of that, let me draw a triangle. So let's say this is going to be my triangle. Okay, so this is going to be my value. The angle is going to be somewhere over here. So this is the theta, and this is going to be my A value. This is B, and this is going to be the hypotenuse. I'm going to put it as being H. Okay, so if I wanted to know what is going to be the hypotenuse value, so the hypotenuse value is going to equal the value of A square plus B square, 8 plus B square, and square root both of the sum. So whatever that you get from that is going to be the hypotenuse value. So when we apply this, Okay, what happened is that for our triangle at the top, so hypotenuse value is equal 25. So 25 is equal a square. So which for this case, let's say a is going to equal 7. So we're going to have 7 square. So plus d square, and both are being square root. So therefore, for this case, when I rearrange, so I will get that 25 square is going to equal 7 square plus d square. So I square both sides of the equation. So that's how it ended up like. So d square is going to equal 25 square minus 7 square. So which for this case, if you use your calculator, so 25 square minus 7 square, so that is going to give you a value of 576. But that is going to be a value of d square. So what is going to be the value of d? So when we square root the value, so that is going to give us a value of 24. So therefore we know that this d right here, so this is going to equal a value of 24 units. Okay, now that we have all this value, then straight away we can find what is going to be the value of cos theta. So cos theta, so according to the SOHCAHTOA rule, so it's going to be adjacent over hypotenuse. So what is going to be the adjacent value? So adjacent value is going to equal 24, and the hypotenuse value is going to equal 25. So basically, cos theta is going to equal 24 over 25. And what about cotangent of theta? So cotangent of theta, so cos is going to equal, so according to what we have over here, so cotangent theta is going to equal adjacent over opposite. So what is going to be our adjacent? So adjacent is going to equal, the reason is that when we have tangent theta, so it's going to be TOA, it's going to be adjacent over opposite. So when we have 1 over tangent theta, which is equal cotangent theta, so that is going to be the opposite way, which is going to be adjacent over the opposite. Okay, so it's got to be adjacent over opposite, which for this case is going to equal 24, and the opposite is going to be 7. So the cotangent theta is going to equal 24 over 7. Okay, so that is going to be for right triangle. So now that you are familiar with the idea, so the fact that we can use this property, so SOHCAHTOA, in order to find the trigonometric ratios for the case of right triangle. So we are actually going to apply that idea for which when we have cases like this. So this is a very common final exam question. So we gave you a scenario and we wanted you to visualize whatever that's happening, the scenario, and do the calculation to find some values. So here the question says that you have a person standing 100 meters from the center of the base of the Eiffel Tower. So roughly the idea is going to be something like this. For example, let's say this is going to be the tower. So I'm really bad at sketching, so please just ignore my sketching. So let's say this is going to be my tower. Okay, so this is going to be the center. So the person is standing 100 meters away. So the distance between this person and what do you call that, and the base of the Eiffel Tower, so it's going to be 100 meter. Okay, let's say this is going to be the person. So I'm going to put the person as being an X. So this is the person. So it says the angle, okay, the angle of elevation. So in Malay, angle of elevation is known as sudut dongak. So means that the person is looking up. So when you look up, so automatically your eyes is going to be leveled above. So your chin is going to be up as well. So angle of elevation is sudut dongak. So you are looking up. So this is what happens. So the person is looking up here. So basically this is going to be our tower. So it says the angle of elevation to the top of the center of the tower is 71.6. So the angle created that the person is looking up, so this is actually 71.6 degree. So how tall is the Eiffel Tower? So we want to know what is going to be this height. So let's say we're going to represent this height by being h. So here what we have is going to be a couple of values. So we have the value of theta. We also have the value of adjacent. So this is adjacent right next to the angle. And we wanted to relate that with the opposite, so which is going to be h. And we know that from the formula that we had. So for the case of that relates between opposite over adjacent, so you can actually use the tangent because tangent is opposite over adjacent. So can you actually use cotangent? Yes, you can also use cotangent as well. But our problem is that in our calculator, that is tangent, but there is no cotangent. So therefore, instead of using cotangent, we are going to use tangent. And tangent is given by opposite over adjacent. So that is how we come out with this thing over here. So because tangent of theta is going to equal opposite over adjacent, so we have tangent of 71.6 degrees is going to equal the opposite, which is going to be the height of the Eiffel Tower, h, over the adjacent value, which is going to be 100 meters. So therefore we rearrange, so h is going to equal 100 tangent of 71.6 degree, and the outcome is going to give you a value of 300.61 meters. I think that the question when it comes to this topic is going to be super simple, but the only challenge will be having to visualize. So when you come across something like this, so don't expect all the time that the visualization, that the picture is going to be given. There are certain times that we only give you a statement like this and we expect you to be able to visualize. So for cases like that, so you have to read the question very carefully and try to make a simple sketching so that you can actually answer the question. So as usual, so I've given you like a couple of questions over here for you to try, and some of them are actually final exam questions and even the solution as well. All right, so